This next separable equation requires a little bit of trigonometry.
I know.
Great. I'm glad you know.
I'm so ready.
So let's dive right in there. Secant of y dy dx plus sine of x minus y equals sine of x plus y. And you're first thinking, how on earth are we ever going to separate that?
How dare you?
Well, I dare do that because I know something. So secant of y dy dx plus now sine of x minus y. That's sine of x cosine of y minus cosine of x sine of y. Doesn't that simplify things a little bit? And this equals sine of x plus y. Well, that's sine of x cosine y plus cosine x sine of y. Aha! So now what happens? Notice we have sine of x cosine y on this side, sine of x cosine y on this side. And this we have cosine of x sine of y with a negative sign on it. So flop it over on the other side. We got two of them over there. So we got secant y dy dx equals 2 cosine x, cosine x sine y. Now it's starting to look like something that perhaps can be separated. We'll divide both sides by sine of y and multiply by dx. And we'll reach this stage, and here we have the variables separated.
I agree.
Great. Now, what are we going to do with this messy looking left-hand side? We certainly can't integrate something that looks like that. Well, this might help. You might recall that the sine of 2y is the sine of y times the cosine of y. I'm sorry, 2 sine of y cosine of y. So if we said this was sine of 2y over 2, then that would change this whole side into what I have right here highlighted. But that's really, when you divide by 2, it's like when you divide the denominator by 2, it's like multiplying the numerator by 2. That changes this to 2 times the cosecant of 2y dy. The right side is just 2 cosine of x dx. So suddenly we have a fairly nice looking thing, and it is separable.
I can't wait.
All right, well, that started kind of nice, but I have to confess something. It's not easy to integrate cosecant of 2y.
I am so glad.
Well, I guess we'll have to see about that. So, I don't know if you remember ever doing this in Calculus 2. I can see that you do. Okay, what you have to do, you have to take the left-hand side and multiply it by 1 in the form cosecant of 2y plus cotangent of 2y divided by cosecant of 2y plus cotangent of 2y, and then integrate with the u substitution. So here's what you wind up with. This is awful looking thing. We're just doing the left-hand side right now. Hey, doing the right-hand side is a piece of cake. Negative sine of x plus c. Done. But the left-hand side is this ugly thing. It definitely is ugly. Yeah, you all agree. Okay, so once you've done this multiplication, notice you got cosecant squared and cosecant cotangent in the numerator, but down here you have cotangent. By the way, the derivative of cotangent, is it not cosecant squared? And the derivative of cosecant, is it not cosecant cotangent? So now you see, let u equal this. Ba-ding! And du would then be negative 2 cosecant 2y times cotangent 2y minus 2 cosecant squared of 2y. My software won't let me put that 2 in here where I'd like to. I have to put it, this means not the cosecant of the quantity 2y squared, but it means the cosecant of 2y, that quantity squared. So my software just won't let me type it the way I'd like to. But you have to interpret it that way. Anyway, then the integral becomes negative a half, that's from this negative 2, du over u, negative a half ln of u, plus c, which is negative a half ln of cosecant of 2y plus cotangent of 2y and absolute value, plus c, and now we've got somewhere. So I just stuck the c over on the right side with the integral of cosine, which was negative sine, plus c, and now we have some kind of implicit solution.
Don't get technical with me.
Well, I guess it is kind of technical, but I certainly wouldn't want to try to do anything like make both sides exponents for e. Well, I guess I could. Maybe multiply both sides by 2, make both sides exponents for e. I could try to come up with an explicit solution, but I don't see it happening. So that's that. I'll leave that go.
I don't know what all this trouble is about, but I'm sure it must be your fault.
Yeah, it probably is my fault. I picked the example.